Hey everyone, in this video I will be discussing about pointers. What are pointers in C++, and one of the most important concept in C++ programming language is pointer. So through pointer you can directly access the memory. How we can do all those stuffs we will discuss in this lecture completely. So let's begin. So a pointer is a variable that stores the memory address of another variable. This line is the definition of pointer. So what does this line you will be getting after you watching this video? Okay, so let's start and let's creating how to create a pointer. So I'm including iostream file. So basically, as we always creating, let's say let int a is equal to, let's say, 5. So in memory, what has been happening? So there's a variable called a, and in that variable you are storing some values. What is the value here? The 5. So 5 has been stored in a. So if I want, what I want to create a pointer, and this pointer will pointing to this address of this a. So how we can do this? So let's create int star, let's say ptr. So it's just a syntax, you don't have to remember it, but you know that how. So you have to be careful that when you are creating a pointer, when there is a star over there, then you have to just notice that this must be a pointer. So what a pointer basically gets, or what a pointer holds or stores, so it must be an address. So what kind of address is it could store? Address of a variable. So if you want to just print out its variable, its address, so how you can do? So just by doing all those steps like cout ampersand a. So this is how you can find it out, that what is the address of this variable. So you have to store this thing. Okay, so how you can do? Just by that. So this is how a pointer is defined. It means that the ptr is pointing to the address of this variable a. So let's print it out so that you can easily understand what has been happening. So what I'm printing over there, I'm printing this statement. If you have any problem, then I will be doing for a fresh. Okay, so this is printing, what it is printing? Ampersand a. Ampersand a means the address of a. So this is in hexagonal format. Okay, so let's read all those stuff that I have written over there. So a pointer is a variable. Pointer is a variable that store the memory address of another variable. So this is how pointer is a variable here, and this variable is storing a address of another variable. So this is the another variable a. So this is the example, that example that I have been created over there, that int a is equal to 10 and int star ptr is equal to ampersand a. So here both has been same. So why you should learn about pointers and why use pointers? So basically, whenever we create a memory here like that, so it is created in a stack based, but this kind of thing is not very good for our efficiency for memory. So that's why we can create memory in a heap. So at that time, when there is a dynamic memory allocation happening there over there, so there where the concept of pointer is being used. Okay, so let's move forward. And dynamic memory allocation, passing data efficiently in a function, we will learn all those stuffs, what it is. When you solve some questions based on that, then you can easily find it, or it is useful in linked list. When I teach you what is linked list, then you will be getting that in each and every problem there is a concept behind a pointer. So if you are not basically familiar with pointers, then you can't solve a problem on LinkedIn not linked list. Okay, let's move forward. How to declare a pointer and initialize a pointer. So declaration, so this is the basically syntax int star ptr. So this is the syntax which I has been created over there, where it is this. Okay, so basically the same thing which has been already I have told you. So the pointer store the address of a. So here this ptr is storing the address of a that I have already been explained to you. So if you don't have the address to store something, like if you want a pointer, let's say this in star ptr, and which is basically pointing to nothing. So you can't ignore like that and just you can't print it out like so. I think it must be giving some kind of error, or if it's not giving an error, that's absolutely fine, but you don't have to do all those steps because it's a very bad practice, because it is accessing some illegal memory access. So that's how you, if you don't have the address of another variable to store, you always have to assign this ptr with null pointer or null, and then if you print this stuff, then it will be absolutely fine because it will be pointing to 0. So that's how it is going to be happen. Okay, so let's take for another example for a floating point, and you always you need to understand what is the size of this ptr variable. That, so let's play for that, but I'm creating for this thing like that. Let's say float a is equal to, let's say, 3.4, and float star fptr is equal to address of a. So this is how we can create a pointer for this a variable. You can print it out. What if you print a, then what will be happening? Let's print for the address which is stored at a, and let's print for what is ampersand, sorry, dereference of fptr ptr. So let's print out all those stuffs. Okay, so as you all know, this is equal to 3.4, which has been the output of your first this statement, which is on line number 13. After that, you are printing the address of a, at which address this a has been stored, which is this address. And after that, in line number 15, you are basically dereferencing that you go to this address and then see what is the value which is stored over there. So this is, as you all know, this is 3.4. So that's how all the things has been working here. So let's move forward. So dereferencing a pointer, so is what it is, so accessing a value stored at memory address. So if you want to access data from the stored memories, then how you should do, let's see. So this is how int a is defined as. So here, let's say, basically you have this kind of things which is a, and in a 20 has been stored. Okay, so how it is, so this is, you can see very clearly. And a pointer ptr, what is pointer ptr? So let's say the address for this is, let's say, 1000. Okay, the address of a, let's say. So if you print a, then answer should be what, 20. Okay, so what it is 20. If you print ampersand a, then it will be printing to 1000. Okay, so I have another variable which is ptr, which is your pointer ptr, and this is storing this 1000 address of this a, which is pointing to this memory allocation. And let's say its address is around, let's say, 216. Let's see. So let's play what is happening over there. So if you print, just go on ptr and see, so what it is there. So it is 20, so that's why it is printing 20. If you modify these things, so just go and do some changes in this memory. So if you do this thing, star ptr, and you just assign with 30, then this 20 has been replaced and there is 30 which has been stored in the a. So that's how all things has been happening. So if you, after that, if you print a or star ptr, then it will be printing to 30. So let's move forward. So let's do for pointer arithmetic. What is pointer arithmetic? So you can do all those things with arrays. So what is here? So you have a array, this, and in this array you have three elements, which is 20, 10, 20, and then 30. Okay, and you have a pointer. Let's say the base address for this array is, let's say, 104. Let's say, and there is a pointer which is your ptr, and it is stored this value 104, and it is pointing to this first block. Okay, so if you print, just go to this ptr plus 1, so what it will be printing? This 20. So this is how the whole thing is working. You can traverse it if you do all those steps. Let's create something here for your better understanding. Let's say let int arr is equal to, let's say, 10, 20, 30, 40, and then 50. And if a pointer star ptr is pointing to this arr, and if you want to just print from this ptr variable, then how you should do? So if you do int I is equal to 0, I less than, what is the size? 5 is the size of this array, and just if you print star ptr of I. Okay, so it is not working. Let's say okay, so let's see what is happening. Yes, so it is absolutely fine. It is printing all the elements through this ptr variable. So let's see what is happening over there. So you can do all those steps, and you can traverse that. I have traversed it, how you can traverse it. Okay, so let's move forward. So pointers and array, that I have told you. So pointers and arrays and pointers are closely related. So this is the array which has been given in your problem, and this is the pointer ptr which is pointing to this arr address. So if you just print ptr of 1, then it will be printing to this element. How? Just see it. This is 1, this is 2, and this is 3. The address for first is, let's say, 100, the base address of this array, let's say, and you have another ptr variable which is the pointer, which is pointing to this base address of this array, this arr. Okay, so if you directly see that if you want to print this ptr of 0, then it will be printing to this 1. If you print ptr of 1, it will be printing to 2. If you want to print ptr of 2, then it will be printing to this element 3. So that's how why this output is equal to 2. You can iterate through this, and that I have explained in the previous slide how it is working. So let's see what is dynamic memory allocation. So basically, use new and delete for dynamic memory allocation. This is some sort of, basically, what should I say, it is a syntax for doing all those things. So let's make something. So if you create these kinds of things, so let's say I am creating here, so you can understand better. Okay, so int star ptr is equal to new int. So this is how you can dynamically allocate something. So if you want to store something in that variable, let's say ptr, and if you want to store, like, say, let's say 1, and just print it out. How you can print it? So just ptr, then it will be printing, or the giving output should be equals to 1. Okay, and you can also print its address. What is the address of ptr? So you can directly do this, because if you directly print ptr, then it will be returning some what address. Okay, yeah, it is printing this address. This one is stored at this address. Okay, so after that, if you use all those stuffs, then you have to delete something. How to delete? Using delete keyword, this delete keyword. Okay, so after use of this ptr which you have dynamically allocate, then you can delete it. How you can delete it? Just by using this delete what? The name of the pointer. Okay, so after, if you print star ptr, then I think it will be showing nothing. Yes, it is showing 0 because it has been deleted from your memory. This is how you can use all those stuffs. So for an array, you can you can also do all those stuff. Same thing. Let's say I'm creating a array which is dynamically allocated. So let's say int star ptr is equal to new int, let's say the size of array, let's say 5. Okay, so this is how you can create a 5 size array which has been created in dynamically. So if you do something like int star ptr of 0 is equal to, let's say, 1, and if you do the same thing for 2, 3, 4 and 5, okay, for 1, 2, 3, 4, it is giving some kind of error. Okay, why it is doing? So let's say for star ptr, okay, you can do this for ptr plus 0 is equal to, let's say, 1. Is it working? Perfectly fine. So if you do these things, and if you do for 1, for 2, for 3, then for 4, bas, okay, because the size is 5, 1, 2, 3, 4 and 5, and let's say 2 and then 3, then 4. I'm just dynamically doing all those things. Okay, after that I'm just printing the array. Okay, so how should I print? Just traverse the whole array. 5 I plus plus, and I'm just performing this operation which is star ptr plus I. Okay, so let's say perfectly fine, 1, 2, 3, 4 and 5. And after all the uses of this ptr, you can delete it. How? delete, delete p t and then r. That's it. After that, if you print all those stuffs, write cout after deleting deleting from heap memory just execute the code. Yes, it is printing 0 0 0 0. Why? Because this 1 2 3 and 5 has been deleted. So yeah, just you can use it different handle for here, and then separate lines for separate lines. Okay, this is 1 2 3 4 5 before deletion. After deletion from heap memory, this is your output, which is 0 0 0 0 and 0. So this is how all the things can be stored in dynamic memory allocation. It is very useful for your avoiding leaks in memory. So this is all about this lecture. So guys, thanks for watching this video, guys. Till then, goodbye.